Hi, Algebra 2. This is a lesson on Unit 11, Lesson 6, in simplifying trig expressions. So in case you were absent or missed anything, I might not do all the problems, but I'll do enough so that you'll get the idea. So we're talking about trig identities in this lesson. So the Pythagorean identity for trig is sine squared theta plus cosine squared theta equals 1. And then the rest that I'm going to write are just variations on that. So say that I bring that cosine squared theta over to the right by subtracting it. This is what I'd have. Sine squared theta equals 1 minus cosine squared theta. Or if I left the cosine squared theta on the left and brought the sine over, so any of these, they're all equivalent to each other. Okay? But this is the one that you should remember, that top one. Reciprocal identities. Now these we've already talked about. Cosecant is just the reciprocal of sine. So this is easy. Secant is the reciprocal of cosine. And cotangent of theta is the reciprocal of tangent. All right, so that's nothing new. And then we have some quotient identities. Again, nothing new here. Tangent is sine over cosine. Okay, and cotangent is cosine over sine. All right, let's try some problems. So these are sort of what they call them baby proofs. They're not real proofs. Don't think they're the proofs like geometry was. So we want to write an equivalent trig function for each of the following expressions below. So 1 minus sine squared theta. Well, we know that 1 minus sine squared theta is equal to cosine squared theta. We had that up here, right? 1 minus sine squared theta equals cosine squared theta. And then I have cosine squared theta on the right as well. All right, so basically these are equivalent to each other. Cosecant of theta times secant of theta equals 1. So I'm just proving these. Well, cosine is just cosine. Secant is 1 over cosine, and I'm trying to prove it equals 1. Well, if I was to multiply this, I would get cosine theta over cosine theta, and that is just equivalent to 1, so I did it. C, sine of theta, I'm going to leave as sine of theta. Secant is 1 over cosine theta, okay, and tangent is sine over cosine. So on the left, if I multiply that, I have sine over cosine, and I already had that on the right. So it's just making them look alike, finding their equivalent forms. So that's all good. And if I come down here, sine of theta, I'm just going to leave as sine of theta. Cotangent is cosine over sine. And on the right, I just have cosine. Well, the sines on the left cancel, and I just have cosine of theta equals cosine of theta. Done. All right, next one. E, 1 minus cosine squared theta. Well, we already know that that's equivalent to sine squared theta. And basically, sine squared theta just means that I really have two sines. And the two that I have on top, one of them can cancel with one of the ones on the bottom, and I'm just left with sine theta equals sine theta. All right? And sine of theta, this one's a little bit trickier. Sine of theta is just sine of theta. Tangent is sine of theta over cosine of theta, right? So tangent equals that. And on the right, I have cosine theta. Now, when you're dividing, remember when you're dividing fractions, you change to multiplication and flip the second fraction. So it's going to become cosine theta over sine theta. And look at that. Those are going to cancel. So once again, you made the left side look like the right side. All right? These are just identities, manipulating everything. So here's some rules. Where they go? Simplifying trig expressions. Here's some tips. Try rewriting all the trig functions in terms of sine and cosine, because those are the more basic ones. If you have any that are 1 minus sine squared theta or 1 minus cosine squared theta, that should be, telling you to use that Pythagorean identity. All right, so that should look familiar. Try factoring out a GCF if possible. Don't forget about rules used with numbers. If you're dividing fractions, you keep the first fraction, change to multiplication, and flip the second fraction. Squaring a binomial, don't forget you're doing that double distributing. You're basically foiling. And then if you are multiplying by the conjugate of 1 plus sine theta is 1 minus sine theta. All right, we'll try a few more. Expressed in simplest form. So this I'm just writing in simplest form. I'm not really getting the left side to look like the right side like I did before. So cosecant theta is 1 over sine theta. Tangent is sine over cosine. Oh, and I made a mistake. I wasn't adding these up. So let me get rid of that adding sign. I'm multiplying these. And cosine is just cosine. So let's see what I can get rid of. So I got this cosine, this sine. Oh, everything canceled. It's just equivalent to 1. All right, the expression cotangent over cosecant is equivalent to what? Well, cotangent equals cosine over sine. Cosecant is 1 over sine. But now remember, I am dividing those. So let me just do it like this. So I got cotangent of x, cosecant of x. So cotangent we said was cosine over sine. Cosecant is 1 over sine. So I'm going to take this and I'm dividing. I'm going to change to multiplication and flip this second fraction. And then look at that. Those signs are going to be able to cancel out and I'm just left with cosine. All right, let me see if any of these are any different. Not too much different. Let's flip over and just look at what's on the back here, just so you can see. Short response, using trig identities in order to answer the following questions. Express cotangent of x sine of x over secant of x is a single trigonometric function in simplest forms. So cotangent, I'm just going to write what each of these are equal to, is cosine over sine. And secant is 1 over cosine. All right, sine is just sine. So I'm going to rewrite that. So cotangent, instead of writing cotangent, I'm writing cosine over sine. Sine is up there already, so I didn't do anything with that. Over secant, which is 1 over cosine. So these cancel, and I just have cosine of x. I'm going to change to multiplication and flip this second fraction, right? This one's got to get flipped. So that's just going to be cosine squared of x. All right, I'm going to skip this one. And to prove trig identities, change the more complicated side to look like the simpler side. Do not change both sides, so that's pretty important. So I have secant of theta is 1 over cosine. Sine is just going to be sine. And cotangent is just going to be cosine over sine. All right, so let's see what we can cancel out. I got the cosines canceling and I got the sines canceling. Oh, I did it because I had equals 1 on the right and now I have equals 1 on the left. Okay, so that should give you an idea of what we worked on in lesson 6 right here.